Good morning, everyone. Today is December 16th, 2017, and this is the John Chappell Natural Philosophy Society Saturday Science Chat. And here at the John Chappell, we are seeking the truth in science. And so we have our websites, and we invite you to be a member of our society. And we have forums, and we're on Facebook, and we discuss science just like we're going to do today. And today we have Slobodan Nedic, who is going to be discussing ether-dynamics. So let's go and put up presentation, and I'll let you take it away, Slobodan.
Okay, Franklin, thank you. So here you have the slide with the title Ether-dynamical Essence of Electromagnetism. It is according to Ether-dynamics of Lachukovsky. In the next slide, I have one, list of items with motivation and overview. So the motivation for this particular presentation were numerous email discussions, in particular related to the cat's question, and just recently related to the still unexplained Faraday monopolar induction, even mentioning some kind of problems there. So it is kind of a continuation presentation that I had on July 8th this year. It was about atomic and molecular structures in the context of ether dynamics. Again, it was motivated by discussions on the configurations of structure of nucleons, atoms, molecules, and so on. That presentation is given here on this link. And for this particular one, I have in mind two partially translated subsections that can be found on this link. It's actually chapter 7 and chapter 8. The last time I did not talk in advance about kind of introduction to Lachukovsky's ether-dynamics, and I will do it this time. And after that, I will focus on the structure of and dynamics of electron and the nature, essence of electric field. And after that, continue with the nature of current in the conductor and the related magnetic field. And in the end, some discussions would be due. I mean, some kind of conclusions or suggestions. So, that kind of vortex ring structure where the smoker's ring turned out to be good, analogon, has been kind of not accessed, happily by many of people. Here, when I show these slides, how these structures look like, how they can be produced by man and by animals, in particular here by some dolphins who play with self-constructed vortex rings. I would like to stress that actually when we look, for example, in one of these pictures in upper part of the slide, that actually we should imagine that we have all room filled with same kind of fluid or gas, same kind of smoke, maybe under very high pressure and so on. So that all these processes induced or even spontaneously happening happen in such an environment. Because we are talking about ether, it is kind of substrate that is characterized by viscosity, compressibility, very high pressure, relatively low density, high ultra luminal velocity of fluid particles, and so on. Here's just one picture from dating from maybe 120 years, 150 years ago or something. For example, configuration of vortex atoms. In this context, vortex ring, given by Sir William Thomson. That will be basic structure that we were talking here about when we talk about proton, electron, even photon, and so on. And the nuclei, atoms, molecules, actually conglomeration of such structures from lower to higher scales. So here are some information, some insights, some results actually from experiments conducted in the domain of quantum mechanics, where they succeed to separate particular vortex ring into two parts, claiming that it's kind of magnetic monopoles and so on. These structures actually are consisting of movements of particular particles or fluid elements which actually inscribe or form structures that are likening the smoker's ring or vortex rings, toroidal vortex ring, donut shapes, forms, and so on. On the right-hand side, we have actually distributions of densities, velocities in different domains of such structures. It's very important to, have in mind when they're talking about this, say, ether-dynamics or gaseous dynamics. Might be a little bit kind of maybe abstract, and on the other hand, maybe too simple, too engineering or too kind of, not that fancy, I would say, but by all means effective. So I may have kept too many of these slides here just to get an idea how it looks like in the space. And this is a representation that Wilhelm Reich had a long time ago, maybe almost 100 years or 60, 50, 60 years ago, how this structure looks like. Amazingly, he was really up to something. So here is kind of presentation of view of such vortex in the plane of equator. So how to say? So we have the movement that goes in the direction from one pole to the other, and not shown here, we have also motion outside of this domain into this domain. When we are talking about electric and magnetic charge, electric and magnetic monopoles, we may think of kind of reshaped such forms. So that, for example, magnetic monopoles would be really kind of squeezed such forms along axial direction. We will see later is very important because magnetic field is related to the movement along meridian direction and electric field along the equatorial direction. This might be kind of electron-positron form and maybe magnetic monopoles structures, plus and minus. Topologically, mechanically, or whatever, people who are dealing with the gas dynamics, based on which actually this work of Petrukovsky conducted for last 50 years, started from noticing some problems with the Maxwell's formulation of electromagnetism within his work on transformers design, exploitation, and underwater communications, and so on. Those people don't bother about really kind of finer structure of those forms of those particles of gas, in this case, so-called amers, the name that actually Democritus had given to such presumed particles. But when we look at the kind of form of magnetic monopoles and so on, we can think of gyroscopic structures, which actually precess in the process of collisions. And even with Navier-Stokes equation, they are shown to tend to inscribe the structures of toroidal vortex as kind of depicted and kind of hinted here. Internal structure may turn out as some kind of embedded, how say, helicoids, or kind of like kind of scale wise, or say, organized structures that remind kind of torus transformers and so on. We should have in mind actually that that in such configuration we have composing flow both in the direction of equator and in direction from one pole to the other. Here's the list or table containing the ether parameters deduced, induced in combination based on many of measurements in particle physics, in quantum mechanics, electromagnetism, some new experiments, and so on. We have here density, pressure, specific energy, temperature, first and second velocity. Kind of first velocity would be something like velocity of light, c, and the second velocity would be kind of actually the first velocity would be kind of superluminal velocity, and the second one would be what we know as a light velocity, or velocity propagation of electromagnetic perturbations. So heat conductivity, kinematic viscosity, the dynamic levels of viscosity, heat capacity, and so on. And then mass, diameter, unit volume, average speed, average length, and so on. These parameters really can come out from and contribute to very consistent elaboration and formulation of ether-dynamics in general, where electromagnetism comes just as one segment. When you're talking about electromagnetism, based on this approach, Ostrowski had extended Maxwell's equations. So here, on the left-hand side, conventional form, or on the right-hand side, in kind of integral form, we have here the parts or signs which are inserted in addition to what Maxwell equations already contain. So we here essentially non-zero divergences of electric induction, and essentially non-zero divergences of B induction, so of electric and magnetic field in ether outside of the structures that can be considered as charged ones. In general, you know, there's kind of classification of flows in such a substrate: diffusional, progressive, rotational. That's actually how the book starts with. Then kind of explanations of particular forms of those with some additional formula about densities, velocities, and so on. I will just really quickly go over these here. We have kind of two typical forms. One is with open ends, for example, as in tornadoes or some other forms. I mean, historically, traditionally, considering the ether as ideal fluid without viscosity and without compressibility, it has been considered that vortexes can not appear or disappear. And this type of vortex can be only attached to different medias. This one cannot be either made or disintegrated. In the context of ether dynamics of ether as a gaseous substrate with viscosity and compressibility, the situation is totally different. So we can have spontaneous creations of such structures or induced creation of them. So are you with me? I'm just to check because, you know, kind of. Franklin?
Yeah. Yeah, we can hear
Okay,
you.
good. Okay, good.
Although you're a little bit quiet. You might want to speak up or get closer to your microphone,
Okay.
but we can hear you.
Okay, here just some illustration taken from the book. Actually, just recently I came across an old album with different forms, topologies, structures within the fluids in general. For example, one can see here cross section of toroidal vortex in the gas fluid. Here is actually, this should be here cross section of this smoker's ring here. This here shown kind of hierarchical organization of such vortexes, for example, when drop of tinta, I would say, that falls into water, it tends to branch into similar structures, then lower level vortexes branch into smaller ones, and so on. So maybe too much of this introduction, but here is kind of structure of proton. So here is kind of cross-sectional area from one pole to the other. Here is cross-sectional area over the plane of the equator. We have indicated the movement of the particles. Maybe on the next slide, we have here distributions of velocities, densities in both meridional, polar, say, direction, or equatorial direction, which resemble those that had been measured in quantum mechanics experiments that I showed before. Here is kind of interaction, possible interactions between two of them. It's very important here to have in mind, to keep in mind that in the, substrate as ether or some gaseous volume under high pressure, when we have movements that are going in opposite direction, in those situations,
Are you still there? You seem to have cut off. Is anyone else here, Slobodan?
Nope. No, I can't hear him either.
Oh, he seems
okay,
to have been...
I was cut off, so...
Yeah, there you are back again. All right. Yeah, we lost you there for a second.
So when we have the movement of those particles, which are counter to each other, what happens is the increase of gradient of velocity. That means decrease of pressure. So that here we get lower pressure, so that outside pressure becomes higher, and those two structures get pushed to each other. Or if we have movement in the same direction, we will have kind of a repulsion of those two structures, because we have here reduced the velocity gradient and increased pressure. So pressure here is higher than outside. So those two structures get pushed from each other.
Oh.
I mean, here it's very interesting kind of, because some models of how say particle dynamics that, for example, in particular Bob the Hilster and David have been developing is totally how say different from here. So totally counter. They actually have a kind of repulsion when those particles have a different how say counter directional movement. This really, I guess, kind of misconception, and they don't have the substrate which has kind of pressure that consists of all the way same particles with very high ultra luminal velocity. and so on, to think then of gaseous mechanics and dynamics. Here are some kind of additional information. So it would be important to have in mind here actually that what electric field is. It is actually the mechanism of flow around the equator, with this mechanism of two such structures being pushed from each other or pushed towards each other. The dependency of such force on distance between them is 1 over r squared. Similarly, magnetic field turns out to be related to the flow of ether particles in the meridian direction. The dependency of the force in that case is proportional to 1 over r to the third degree. And we have actually kind of two curves with crossing over and have actually kind of mechanism of oscillator, or even, or at least possibility for have quasi-static equilibrium in particular situation, which can be the case on atomic level and molecular level, as has been shown in previous presentation, and what many of the participants of those conversations in the email are supporting, as Roger Riding, for example. What is interesting here, actually, this force then becomes kind of extended, Newton's force with the explicit centrifugal component. And what is more interesting, the same form we have actually for the force of gravity in the general theory of relativity, both as Einstein defined it, as Roger, as Ron Hedge had it alternatively. The issue is only that those constants are not well motivated. Here we have something that relates to magnetic attraction or repulsion. So gravitation becomes electric attraction or repulsion, and anti-gravity becomes something as magnetic repulsion of attraction. Maybe on molecular level, atomic level, we have all these combinations in place. Oh, this is actually, I made mistake here. Actually, I should have here this highlighted. So we are going here to this bullet. We are going now to the discussion of structure of dynamics of electron and the nature of electric field, what I in a way partly just mentioned. And later we go to this part. I confuse these two things. So when you have a metal, then those atoms that are combination of nuclei and the electronic shells, again flows of ether of particular form, grouped more or less. When they are next to each other within a metal, then we have something like metallic bonds or covalent bonds, where actually those flows get reconfigured so that when a number of atoms get to form another kind of molecule or conglomerate of those atoms, part of those flows gets released because kind of the length of those flows is longer than this one, and this comes as a super flow, for example. So they restructure and configure into the toroidal vortexes. So we have the compound of atomic or metallic atoms, and then we have something as free electrons. Those free electrons have the same form as toroidal vortex, kind of that smoker's ring and all those similar structures. Now, when we compare the structure of proton with here indicated flows of ether in the equatorial domain or ring ring-like. Comparing with the electron, we have actually counter movement along the equator. Otherwise, the same configuration. Of course, densities here are different than here. Maybe this is of smaller volume, definitely so. This is of wider volume, or vice versa, I'm not sure. And then here, I put one paragraph here and underlined it, having in mind relevance for the later, not yet here resolved. Here is just kind of introduction and kind of creating a basis for future work on the explaining the Faraday kind of paradox, or Faraday monopolar induction mechanism. So if the if an electron falls in an area where there are any ether streams, and magnetic field will be shown later, actually is presented by particular form of streaming of or flowing of ether. Then as velocity gradient of those flows increase, the pressure on the electron surface reduces, and the vortex rings increase in size. So we have kind of here maybe something kind of counterintuitive. This is the structure, or maybe kind of form, of the electron in metal, and in free space is like here. So higher pressure is acting in the free space than within the metal itself. Now, on the metal surface itself, the electrons get structure, so they kind of they form this pattern of up and down directions of this kind of main axis, and then this create kind of Fermi's metallic surface. So when we electrify, if metal, if possible at all, maybe on some materials which are not metallic, we have similar, maybe not that or very well ordered configuration. But when we rib those surfaces, we actually turn around those electrons and get one polarity on or the other, and get charge of that body of one or the other side. When we have an electron fallen into field created by another electron, or a set of electrons, for example, the surface of certain ball, or certain, let's say, plastic ball or whatever, what we have actually, we have a repulsion of this electron from these electrons here. All of these electrons here actually induce the, how say, helical movement of ether, both out of that particular body or that particular electron and back to it. Here we have the situation. I indicated here the flows of ether along the let's say circular direction, equatorial direction, to coincide with this one. But this is looked from different sides, so actually it's important to know that actually the movements are of same direction, should be of the same direction, so they repel from each other. So it's very important to notice here actually that is given here in this paragraph, that the force that acts here is of this form. And actually, it is something that has been detected a long time ago, and that kind of this is related to the kind of relativistic increase of mass and so on and so on. But actually, it turns out that there is no anything related to kind of really mass increase. Those inability to accelerate electron beyond certain velocity is not related to its mass, but is related just to fluidomechanical, dynamical aspects of pressure, increase, decrease, equalizing, and so on. So now we go to the current in a conductor and the related magnetic field structures and essentials. You know, very old conceptualization of the, how to say, magnetic field and the kind of magnetic induction was actually that you have this kind of form, stick that has these shapes, I don't know how I would describe them, and the current is actually represented by the movement of this stick, and that stick is actually buried in the sea of gears, as shown here. So when this is moving up and down, those gears are turning around, and if we have another, I'll say here, what's the name of this stuff? The I say stick or here, then actually those rotations of those gears would be pushing this counterpart structure up and down as well. It's interesting that actually in Ether-dynamics formulation and conceptualization, representation, a very similar situation is taking place. Maxwell had kind of the kind of visualization of the magnetic field, a set of vortices mediated by some so-called idle gears. He could not come up with what those gears would be, but actually here turns out that it's not necessary to have such elements explicitly given there. It's just part of composite mechanics and dynamics of those vortex flows. A magnetic field was imagined and kind of measured and experienced as kind of having lines of force concentric around conductors and so on. Not necessarily that the how say plane of those field lines should be kind of really kind of perpendicular to the axis of the conductor with current. Okay, here the issue of whether there is divergence outside of the charge or not. This is something that has been kind of really entrenched into the conventional formulation of electromagnetism, which is big, I'll say, drawback or mistake or I'll say shortcoming of such formulation. When we have a conductor, we say with current, or better put it conductor, which is put into the field, electric field. So we have see here plus pole and minus pole of a battery, for example. What is happening is not that those electrons of the form of toroidal vortices, as shown before and indicated here in this and this way, that they start moving in the direction of electric field as we showed before. What happens is that their axis to a certain extent decline, rotate, tend to align to the direction of electric field. Only that. So this is kind of shown here in situation when one electron would be really going along, or its axis would be really aligned with the axis of the conductor itself. This is shown that actually those electrons just slightly turn those directions of their axes. Now, actually, the flow of ether along these structures combine, superpose, and then create what we have as a magnetic field around the conductor. Moreover, when we look the structure around this conductor, it gets this form in one subdomain. Again, we have flow in one direction, say direction of current And we have also flow in the counter direction along those, how say, circular flows in between. Let me see what I have on the next. Let me get here. We will see later some like a more, to say more, how say, blown up figure, and we should have in mind actually here that those structures are not fully vertically. We have more kind of skewing here, maybe even up to 45 degrees. But you know, maybe later there will be some indication of that. So now, when we have a conductor with current, actually from those structures, vortex flows of those electrons which are inside the conductor, and in one plane, they just kind of slightly turned around to a certain extent, incline those their axes towards axis of the conductor. They actually induce complementary flows in the neighborhood of the conductor. And what is interesting actually, that electric field is related to the velocity itself. The magnetic field turns out to be related to the velocity of the flow in the circular direction to the velocity of light. So kind of just kind of say plain number. So meters per second, but essentially magnetic field is actually the ratio of those two velocities. It's very interesting. And actually, of course, in those papers in the book, in the translated materials, it has been elaborated really in detail, you know. It's difficult, it would be difficult for me to expose all this here, but maybe would be of help if some clarification for certain parts would be necessary. So here, I mean, around the conductor with current, we don't have only magnetic field that is kind of rotor or curl of electric of the magnetic vector potential, so that the direction of field force is perpendicular to the conductor. We also have a longitudinal component of force. It's essentially kind of scalar force, or maybe something like heavy side, I'll say energy flow, maybe ampere had inside, or some kind of effects in his work. So the composite field is kind of combination of these two, and some also these flows turn out to be certain extent skewed with respect to the normal, to the conductor axis. We should here again notice these composite flows consisting of flow in one direction, say direction of current, or maybe direction of plus to minus or whatever, and the counter directed flow along the circular flows in between. So now we will be looking into this and comparing with the Maxwell's conceptualization. We would be able maybe to find here some subdomains that could be identified as so-called idle gearings. Essentially, I mean, here, when we say what is the magnetic field, what is the current? Actually, current is essentially magnetic field, a flow of ether predominantly outside of the conductor, in particular for higher frequencies, of course. For low frequencies, there might be some drifting here, but really, when I consider something as Katz's question, as I said, should be that question and those issues should be one of the motivation here. We don't have current as flow of electrons inside the conductor, but the flow of induced ether flows outside of the conductor, and those being two-directional. So I think based on this, all those issues that Kat had raised could be cleared, and somehow how say, provide some mid solution between that one what Cat had proposed and the proposition, of course, of the conventional electromagnetics and electrodynamics that current is flow of electrons in the collector. So now, how it looks like with the electron in a magnetic field. I mean, when we have talked about the Faraday monopolar induction, there has been that configuration that has a situation that there is no induction if the magnet, if the cylindrical magnet is rotating and copper plate or maybe that collector, either or collector is not. You know, here I underlined this again, something that could be relevant for that in that respect. So the conclusion insight of the ether-dynamics of Tsiolkovsky is that magnetic field alone cannot in any way affect the orientation of the electron due to the mutual balancing of all forces acting on the electron from the field side, regardless of the structure of magnetic field itself and the predominance of the circular or translational component of the ether movement in it. When it comes to such kind of effect of equilibrium, we have here illustration. You may be looking into this text in parallel. We have two, how say, aspects of view. So, say here is the kind of cross section through the plane of equator, and this cross section through the plane of the meridians, right? From one pole to the other. Magnetic field is presented here by these flows that go into this screen and around those points here. The flows of electrons in ring direction are shown here, and in the toroidal or meridional is shown here. Having in mind that same flows repulse, counterflows attract by inspection and maybe more analysis that's given there, exactly by defining the force, quantities, and so on, one sees that actually the electrons are in kind of equilibrium. So that might be explanation why nothing happens when the say cylindric magnet has blown up range of these pluses and circles around is rotating or not. I mean, we have been talking about kind of invariance of magnetic field, forces, strength lines on rotation and so on. But more important here, actually, the total non-sensitivity of the electrons inside the magnetic field on the presence of whatever additional movement of those fields or those flows of ether. Here I have one slide here, I mean, related to kind of Lorentz force, and so, okay, maybe it might be relevant also for Faraday induction. I had this slide earlier to indicate lack of necessity for Lorentz transformation themselves in presence of Hertz reformulation of Maxwell's equation and so on and so on. But I would not be ready to go over these slides. I just blown up, how say, this previously shown configuration or a part of it to show actually that movement of electron perpendicular to the magnetic field, electron that moves already with velocity Vd is just cause of this balance of pressure of two of this of its sides. So in this situation, what I should have put here, P sub 1, should have put it smaller than P sub 2, or I should have changed the direction of force. Sorry for this mistake. But really kind of explanation is that straightforward for both movement of electron in the electric field and movement of electron in the magnetic field. Here the point had been actually that Lorentz, the Hertz reformulation followed later by Phipps, Wesley, I don't know, maybe Leonard, Roy, Van Flandern, and so on, actually is already contained into properly set up formulation. There is no need for its explicit definition as had been the case in the course of electrodynamics development. So now I have almost last slides, and here I came to this part that is talking about electromagnetic interactions. Later, there are parts of electromagnetic inductions and so on, and I'll be continuing translating that part, and will be encouraged all participants to read the up to now translated part, and later when I provide the rest of it. When we talk about the interaction between two conductors that are situated parallel to each other, and we have this kind of, was it Ampere's law? When we consider what is the current that is actually the flow of ether outside, particular structure of flow outside, caused by slight or partial realignment of the axis of those free electrons inside the conductor, then this mechanism becomes clearly explicable by considering the composite impact of flows of those electrons. For example, here is error. I mean, on this slide, one of these arrows should change direction. So when we look in the currents, they are directions, for example. This is the same directions. We look at electrons in this domain and this domain, and look how they move and what is the direction of flow of ether outside of them. We would have here counter-flowing structures. And then we have increase of velocity gradient, decrease of pressure, and the ether from the surrounding pushes those two conductors to each other. The other way around is when we have a counter flows. Yes.
Did you say that the arrows on the left-hand image should one of them should be reversed?
Yes, one of those sets of arrows. Yes.
So the image is actually drawn wrong. Okay.
Yeah.
Right.
Yeah. This is what I copied and pasted from the book.
Okay.
But
okay.
glancing over it, I noticed actually that for depending, what is direction. I think one of them. I think it was those that goes to the right.
Okay. Thank you.
Okay. Thank you for asking. So now maybe just two slides. Having this lot of discussions. What is the electromagnetic field? I mean, when we have an antenna, put current, so-called current through it, actually drive them by some kind of voltage or some structure of electric field, and have, for example, that intensity of electric field is changing sinusoidally, for example, here. This configuration of magnetic field or the flow around the conductor, actually, in that one of the previous slides, there has been discussion that essentially there is not much difference here, in this part here. There is not much difference between electric and magnetic parts of the structure of the field, say around the conductor. There is just slight difference because electric field kind of coming from this movement on the heads of those tubes, and magnetic coming from surfaces of the tubes themselves, and so on. But anyway, when we look in those configuration, maybe different way, what happens actually? When we say we have a higher magnetic field or electromagnetic field, because this kind of combination of movements, along equator, along, meridians and so on. But what happens actually? When we say we have a stronger field, that means those vortexes, those flows get, downsized. The velocities of movements becomes higher, their densities higher, and so on. And in the other areas, the situation is the opposite. And then, depending on the frequency and the dynamics, we have actually this kind of breathing or kind of pressing and expanding of those flows in the ether outside of the antenna or whatever. And here's how it would like. I have to say that I did not yet really look into this really to understand that you ask me now, what is this, what is that, to be able to answer it to you. But one thing is that this is for transverse electromagnetic propagation. And for example, now maybe to answer this question that Franklin has been asking frequently, or ascertaining that there is no transverse, mechanism or perturbation, asking for the movement to indicate, to show, to measure movement up and down and so on. Actually, we don't have a movement up and down. They will be having movement that is actually acting in this direction. So, for example, if we have some instrument, some needle, some sensor or whatever, then actually it will be manifested as increased force. And essentially, it was increased velocities, increased densities, reduced sizes, and so on. So before it was shown that besides the transversal, mechanism or propagation, there is a longitudinal one as well. And then structure for longitudinal waves would be something shown here. There is some kind of, again, explanation about this difference. Again, I would not be able to elaborate more on this. And I even would be expect that the longitudinal propagation would be of higher velocity than c, but Sukovsky had some arguments here that indicates that actually the velocity of both longitudinal propagation and the transverse is same. So I have here some background slides as well. If maybe some other things should be looked at. But as conclusion, let's voice it this way. Ether-dynamics of rarefied gaseous substrate with compressibility and viscosity provides compelling and consistent model for unified physics on all scales of reality. The essence of electric field is the motion of ether fluid elements in equatorial or ring or circular directions of the toroidal vortex structure or formation. The attractive or repulsive plus or minus 1 over r to the squared proportional forces being related to the reduced or increased, alternatively, pressure or velocity gradient due to the counter or co-directional flows. The essence of magnetic field is the motion of ether fluid elements in the meridian or toral directions, or polar, of the toroidal vortex structures or formations, the attractive or repulsive plus or minus 1 O over R to the third degree proportional forces being related to the reduced increased pressure velocity gradient. So alternatively, outside of the brackets or inside of the brackets. Same thing, but just kind of two aspects. Due to counter or co-directional flows, same as before. So most important thing here, maybe one very important thing, electric current is in a conductor is essentially the helically structured ether flow around the conductor, presenting actually the magnetic field. And with slightly more detailed insight into the behavior of electrons with the magnetic field, and maybe some other, insights, it's very likely that consistent and compelling resolution of the Faraday monopolar induction mechanism could be provided. So that would be all what I had in mind. I mean, kind of to, at least as introduction. I have in background slides. These two are links for these two partially translated sections or subsections. And I have that presentation that I was pay attention of members to my presentation on Tesla Tech 2016 about magnetic monopoles as over unity systems, gearing elements, and so on. I mean, it's about really something that even this kind of alternative or dissident or community that is holding on kind of critical thinking and so on. This aspect of to extract energy out of ether is still kind of something very, very, very strange. Although I just when I looked into the presentation that who was it? Roger Rydin, right? Had those magic numbers, right? When he showed that particular diagram on the left-hand side, this is the area where cold fusion is related to, and which can be used to produce energy. So anyway, I mean, maybe some how to say holistic picture could be gained from this presentation that I have linked here. So anyway, thank you very much for your attention.
All right, thank you, Slobodan. So who's got some questions?
I have one. How do these toroids being generated? By what?
So I gave that introduction, but I can now maybe go to some details.
Yeah, but if they can be generated by something, then the whole theory falls down.
Yeah, they can be. But my point is actually that they can be generated, both generated and dissolved. So in gaseous mechanics dynamics, this is a common thing. I'm not from that field in particular, but for example, different movements of structures within fluid produce certain forms. Even forms of double vortexes that consist electron. I mean, that's really something that every fluid mechaniker or person who is dealing with that will be fine with.
Well, I don't think that the question is whether they can be generated.
Just first, sorry?
Well, I think the question that Hans is getting at is that, it's not a question of whether these things can be generated. Quite clearly, they can be. So that's not the question here.
Okay,
but within within Tefsky's
the question was how they are generated, right?
No, the question is not how they're generated, but what is the mechanism that is generating those toroids within Tefsky's ether-dynamics, because in order to generate a toroid, you might have to like stick a plate in a swimming pool. You know, that it's a very complicated thing to create these toroids. So you might have a toroid gun, but in Artescu's theory, I mean, I think that the point is that there must be a mechanism that generates these complicated toroid shapes constantly.
Yeah, okay.
Just
Okay, can I proceed with the answer? You know, I mean, this big theory, that big work and everything, not being, how say, well-funded in that sense would be really totally ridiculous or some kind of really strange. So we are dealing here with very high pressure, with movements at that particular scale of or substrate of ether, of this gaseous form. So we have a high velocity movement. We have collisions. We have viscosity. We have compressibility, tendency of gaseous mechanics, of Navier-Stokes equations is actually such. It can be fluidodynamically, mathematically shown that the spontaneously structured forms are of that kind. My my personal insight and kind of something that I would be kind of now presenting to you is actually that we may have something like those particles being again some themselves toroidal vortexes, and then they be squeezed and elongated and then act and behave as let me show maybe some.
So you're saying they just spontaneously generate themselves, given sufficient pressure?
So in principle, you know, so second order of thermodynamics in this sense doesn't apply, because there is always possibility for structure be formed in one place and then be formed at the other place, and there's these two forms being pushed to each other, squeezed to each other under influence of that high surrounding pressure, and so on, you know. And then when fluidodynamically or empirically, with the discussions, experience and insights of those people and experiments and results in fluid mechanics and particular gaseous mechanics, they actually confirm that. And here, let me go to this. There is one guy, I showed these slides some time ago, Sarg, or whatever, in Canada, some Bulgarian guy, who had kind of developed his own concept, but there's no much dynamics, pretty much static things, in my view, artificially kind of built up of those structures from very low scale to upper scale. But when we look into the movement of some even particles, not being them kind of elongated vortices or whatever, but just balls, say balls. I mean, maybe say without something that has those distinct movement in two directions or composite movement and so on. When they hit to each other, the only possible, say, stable or preservable structure, changeable, of course, would be this kind of tetrahedron. So those balls will be hitting from each side, sometimes kicking one of those balls out of this conglomeration, but another one will be will hit there. On the other place, there will be similar configuration being formed. And then those are being hit from each side. They are being pushed to each other, you know. And it can be shown easily, I mean, that they tend to form this kind of pentagon. And this pentagon has this kind of slit here, I don't know, maybe some 7.355.
Now, how is this related to Hans's original question about where the torics come from?
Just two sentences more, right? And then such structures being this place, they being pushed to each other, and then creates more complex kind of dodecahedrons or whatever. They become fluids elements for higher level, and they tend actually to get to the structure of kind of prism, and then this slit stays there all the time. Particles on lower level hitting there, turning this around, this becomes gyroscopic particle. When they collide each other, they precess, and by Navier-Stokes equations, they can be shown to inscribe toroidal vortexes. You know, I mean, and then one more question that's related to this. What is the lowest scale? What is the highest scale? I mean, we have apparently here kind of grand recycling situation. So materials, even protons, maybe monopoles or those neutrinos or whatever, coming from higher level structures, from galaxies and so on, creating this kind of substrate. And out of substrate gets up. What is the lowest, highest, those ratio, even golden ratio relationship? This is something that enters into the mathematics and philosophy. I don't get part in these discussions. I just say, okay, let's go to the Cantor's mathematics and the philosophy of infinite, to Descartes' views, insights, Leibniz, and so on. But let's first go to Katz's question and Faraday induction, you know? But because the dynamics sees these mechanics as unified on all scales, you know, he had total, I mean, really dynamics that encompasses all the scales to galaxies and up there.
So I want to give Hans an opportunity. So Hans, do you understand that explanation from Slobodan?
It doesn't help you. Any structured object that you come up with must be generated in some way. So an object that you can start with cannot have any structure. It can, at the utmost, it can be point-like.
Look, I mean, we can talk about quantization, but in a natural way, not in quantum mechanical way. Quantum mechanical way. Look, part of deduction in this development has come actually from quantum mechanical wave equations and so on, you know. But everything is interpreted as densities, distribution of densities, of velocities, not distribution of probabilities, you know. So kind of look at here. I mean, when we have electron, look, when we have electron here inside, right, inside the conductor. Okay, with this form, it will induce the forms outside of the conductor in the ether. So ether is potential, is pressure substrate with basic feature of pressure as a potential, you know, and then actually it structures itself either spontaneously or by induction.
May I just say that I think that the universe is full of angular momentum, areas of angular momentum. And there are laws with regard to the preservation of angular momentum. I don't think that toroids arise out of nothingness. It's already out there, and there are conservations of angular momentum laws that maintain it. It might change. It may transfer from here to there. It might die here and arise there. But there is, I think, a conservation principle. Furthermore, if one studies gases which involve motion that is not symmetrical motion, that seems rather random, you get into something called viscosity. Well, and the viscosity of gases, the viscosity of a lot of things. Well, viscosity has units of angular momentum per unit volume. So viscosity can't just suddenly cease. It's out there, and I think it's out there and conserved because the universe, when it gets down to small regions of the universe, you don't have perfect symmetry at all times.
Okay, okay,
So
sure. I mean, I agree with that. So in principle, I mean, when it comes to conservation of angular momentum in orbital motion, in the context of say methodology and framework that have been developed from the Newtonian mechanics over to the quantum mechanics and so on, and the symmetries, I would not go for that definitely. But as it comes to energy conservation and even angular momentum conservation in general, on the level of universum, that there should be no problem because we would be having actually just transformation on one form of angular motion or angular momentum to the other. In particular, here we have, for example, kind of thermal motion of gas being converted into kinetic motion or kinetic energy, so thermal energy into kinetic energy of the structures themselves. Those structures themselves then get some kind of features of angular momentum. Actually, the angular momentum is not here as something like that is in the solid body mechanics, that we have some, body that turns around. We have here also flows. So we have flows of those particles or elements from lower scale getting into the higher scale. Then those structures become particles for other and so on. So conservation of momentum and could be preserved and supported. And of course, there is no any need, and there should not be any kind of room for symmetries. And actually, modern physics, starting from quantum mechanics now to string theories, go all the time from symmetries for symmetries, for cyclic coordinates and so on. And it had been shown on the level of the orbital mechanics, orbital dynamics of the kind that has been established starting from Newton, and essentially followed by essentially non-changed. The problem is there, I mean, in terms of those symmetries. So there is that energy is not conserved in that particular system, orbital system, as Earth and Sun, but that energy has source for back to come. So in the overall picture, or we can talk about conservation of energy, angular momentum, and so on, but not on particular subsystems.
Well, I think Carl's point there was that, this is one possible answer to where the toroids come from, which is that they've just always been there.
Sorry, that?
Right?
No. Frankly, I mean, really, I really don't care much. This is something that happened in a way serendipitously, how to say, in my case, I hit into the second postulate when I was for GPS in California 10 years ago, and then later started helping this guy here about orbital motion as attraction and repulsion, came across Tchaikovsky's work, got into Ether-dynamics, got everything. So kind of, this is something best that I could offer, and with best, intentions. So, I would not really get into convincing.
Well, how convinced are you of Artesky's theories that we have? How convinced are you that these toroids actually exist, or is this just something that you just think is interesting, or do you really believe that that's how it works?
Much more important question whether this concept works. I mean, is it helping in resolving problems, resolving issues, and really something can come out of the conundrum of physics and mechanics and so on, And then I said There are many different levels. They have structures, and I really don't have any problem. And I don't know. I have all those books. I mean, Cantors and everything to read at some later time to be able to answer these questions. But I don't really see the reason to split the hair kind of here and go into this details. This is gaseous dynamics. Get one of those your colleagues who is working in the field. Start talking to him. Let him show you the album of a number of vortices. Look into the Wikipedia, how those vortices are created in different situations and so on. I mean,
when did that guy?
How is created vortex? Bubbling in the water. When the water is heated, there's really shouldn't be the issue there. Only if one really don't want to look into anything of this kind, then one can then ask. Really. Sorry.
When did that guy live? Did he do his work in the 1800s, the 1900s, or the?
No. Second, I mean, he is still alive now. I think he is in his 60s, 80s, 85, maybe 86. During second half of 20th century, he was leading actually on institute in Russia, I think in Moscow. He lives now in Moscow, I'm not sure. And he was working on as I said before, on the underwater communications and on the design of transformers. And then had been facing different issues, problems, and then that was how he started. He is actually electrical engineer. Has PhD, of course. I now think has some academic title. I don't know from which academy, technical academy of Soviet Union formerly, and now Russia. For example,
Ian had a question.
Okay, he did a lot of experiments in that domain, with transformers, inductions, and so on. With the underwater communications, has one system of communications with longitudinal waves and so on. For example, I have some background slides. For example, the Faraday induction as a rate of change of flux or B, what is wrong, is wrong. And here's, for example, his experiment, If you would like maybe to show to you, we have he has actually indicated compressibility starting from ether substrate to the current. Current in the conductor gets actually in the conductor.
You're still there? We lost you? I think we may have lost Slobodan again there. I see Ian has been waiting patiently, but Ian, I think you're just going to have to wait for Slobodan to take a breath and ask your question.
Oh, okay, Franklin, very well.
Or you can ask the question of the group while we're waiting for Slobodan.
Assuming he can hear me, I could ask the question.
I was cut off now. I'm back now.
Okay, it does follow from what you've just been talking about. I wanted to revert to the ostensible explanatory nature of this, of some unexplained phenomena. You mentioned the cat question, and now you were talking about the Faraday unipolar generation. I'm not quite sure about the cat question. There are a number of questions actually, but with regard to the Faraday induction, I would take issue with you that some model like this is necessary to explain some unanswered questions, because I know we've had a session on this before, and there've been a lot of emails. I've only contributed maybe 1 or 2 emails to it, but there've been thousands of emails on it. But I would contend that there are no unanswered questions with regard to the Faraday induction, both using homopolar and non-homopolar generation. basically any paradox is occasioned by neglect of secondary induction. So, you've sort of said that maybe this sort of model, something like this, is necessary to explain that. Well, I would take issue with that, and I might I might delete that from the exposition of the system, because it's an interesting model which may or may not be correct. It may or may not give correct results, but whether it is absolutely necessary, I would certainly contend that it is not necessary with regard to the Faraday explanation. Thank you.
Okay, I mean, there has been discussion and actually led by Harry Ricker, who has been really working a lot on it, and we were discussing that particular configuration in three forms, and then actually there has been remained problem. I mean, why there is no induction if cylindrical magnet is rotating and other parts are static, and why when we only move the collector we have something. So now, I mean, I thought that actually this insight and this mechanism extended to certain way, or understood better, or somehow elaborated better. By the way, it is the situation where Tchaikovsky himself said that he was not able to come up with a solution. But he is now in his 80s and so on. So it doesn't mean that other people could find it. This behavior of I mean, the understanding of induction itself is very, very, very important. That understanding is tangible and kind of really insightful and kind of open. I'll say things like that. That it will help here. I offer here the particular aspects. I mean, behavior of electron in magnetic field, in the flow of ether in general. I underlined those two paragraphs, and before that I had some idea because I read that part earlier. I think we would be able to do that, and my motivation was, as I said, to provide this to interested people to look at and jointly come up with solutions. As it comes to Carl's question, there is something that here is very tangible, and I had offered earlier the explanation. It's not actually a question, but is related to that experiment that he or some other people in Australia did about the discharge of a capacitor made by the segment of coax cable, charged through the high impedance and so on.
The Wakefield experiment, I think.
Yes.
But one of the papers sent out by Harry Ricker.
That explanation can be. You have actually really as having some container with energy, and then the energy goes out orderly. You have always. What is very important here is always you have flows in two directions. Then one can get back to the issue between Ritz and Einstein, for example, about evanescent waves and outflowing, inflowing, and things like that. I mean, it's very interesting. I mean,
but one of the papers that Harry Ricker sent out with regard to the homopolar generation was one by Al Kelly. I don't know if you looked at that, and one might even forward it to.
Please forward. I mean,
because that has performed a number of experiments, many of which actually were not performed by Faraday originally, and it indicates a sort of an explanation of the phenomena without any new theory, just maybe some slight modifications of existing classical theory. And I think something like that should be looked at first, because the danger with this sort of thing is I suppose what Einstein did with general relativity. He said, oh goodness me, we haven't explained the precession of the orbit of Mercury, so I'll just work on this, and my theory explains that, so therefore this is a new theory which supersedes everything else.
You now know how it is, right?
Doing the same thing. So I'm just questioning you, and I'm saying perhaps you should exhaust looking at the conventional explanation first, which I would contend is actually quite complete.
You know what I mean? this guy did not know for Kat's question, and as I said, did not work out the Faraday induction. So he did not have that motivation, when you look, his references 90% are books from West, mostly of fluid mechanics, gas mechanics.
So that's your own explanation, is it? You've added that his system explains the cat question and also the. That's your addition.
I offered that explanation, but I mean, he didn't know about cat question, right?
Okay, well, I'm just maybe taking issue with you somewhat at that, and you might have a fresh look at some of those things. Anyway, thank you very much. Thanks very much.
If you may send that email, I mean, the information about that experiments or papers, whatever, will be appreciated. Thank you.
I'd strongly advise that you look at Kelly's paper.
Kelly,
just my advice.
C-A-L.
Kelly.
Okay.
There's a book, Challenging Modern Physics, which I think most of it is on the internet, but I think Harry Ricker sent out the full paper.
Okay.
And I can resend it if anybody needs it.
Look, what is the problem here? When someone has had some insights that thinks it would be relevant, the people who are already in some problem, have been working on some problem for a long time and have good information and things like that, it will be easier and more effective for them to take into account that particular insight or suggestion, other than the other guy who came up with this directly or indirectly, to go to all this stuff and then, kind of provide solution. And best way would be to go together, to work together. Why should not be coming up with some solution and joint paper or whatever, what I mean? Okay, I have totally different perspective. People here are looking into their own work, their own theories, but it's totally illusory, that many people with own theories, different theories, contradicting each other and things like that, and not listening to each other, not going for kind of complementarity or overlapping, how to say.
No, I quite agree with that. All I'm saying is I would caution against claiming that these phenomena cannot be explained without this theory.
Let's work together. Let's both hurry. Let's collect those exchanges by email.
Thank you.
I think in the case of Kelly's paper, though, does Kelly go in? I think Slobodon's trying to go more into the characteristics of the electron and the relationship between the electric and magnetic field, and explain it in more depth. Is that not more the case?
Well, I think he is. That is correct. But you see, in passing, he's claiming that you need this sort of model to explain hitherto unexplained phenomena.
You know what I mean? For example, there is that issue that there is, indication, I would say, measurement, experimental measurement, that there is no electromotive force present there where one is expecting it. That's kind of Robert Vallone, right? He did his PhD thesis, whatever, in that domain. He's now a leading person in the domain of free energy and things like that, So there is that aspect, And then the question is, what is the current? What is the electromotive force, So from that point of view, I think that those insights would be very, very relevant. If we know what current is, if we measure something is current, why should we be looking that some electrons are moving there by influence of Lorentz force, when this is clear indication that the current or magnetic field is not caused by the flow of electrons through the conductor, but just by their slight inclination to align the axis of conductor, the direction of the electric field, and then just what we have is induced flow. What I mean? So totally different, perspective.
Maybe we're coming from different ends. I tend to come from the basic end, do the experiments, see does conventional theory explain that? Have we looked at all the phenomena? And then you're coming from the other end. You're formulating a theory as to how these things fundamentally work, what is actually happening in the toroids and the electrons, and then seeing does that explain the phenomena. Well, perhaps we're just coming from different ends. I'm not going to quarrel with you about that. It's only when you made the claim that perhaps one couldn't explain these phenomena without a theory of this nature that I took issue with you. That's the only point.
Okay, what is your name? Could you
I
tell
think
me,
that's
please?
probably that's probably
That's
kind of the
Ian.
case. You're coming from different ends and different depths potentially. Because like again, Kelly is like assuming the right hand rule or recognizing that our experiments show the right hand rule, and I think Slobodan is trying to give a reason for it or a model that could explain why the right hand rule exists.
Yeah, so
If he prefaces his remarks by saying that, there would be no issue. If he says, look, I believe the conventional right-hand rule explains the phenomena and these mutually perpendicular vectors and so on. But by the way, at the very basic level, this is what the ether-dynamic theory would say. Fine, I've no issue with that. It's only when he sort of said that these things cannot be explained without a theory such as this nature.
you may talk to Harry Rickett.
Well, we don't want to get our axles wrapped around things like that. I don't think that's a philosophy of science thing.
Right.
But I think what Slobodan is bringing here is very, very fundamental. Trying to answer things about like what is an electron. And let's, for example, just concentrate for a moment on the phenomenon where we have two electrons next to each other, and they seemingly push each other apart. So, Slobodan has given, a possible explanation for how that works. So I was wondering, are people convinced about that? Do they really think that that's how they are repelled?
I don't understand the model of the torus as an electron and its electric field being some kind of motion circumferentially around the torus. If that's correct, my understanding of that model, because if you rotate that torus, now instead, if you're looking down on the torus, maybe it's that motion is clockwise, but if you rotate the torus and look from the back, that motion is now counterclockwise. Have you just changed the sign of the chart?
Yeah, sure. Then it becomes something like positrons, so they attract each other.
But that's just a point of view. Franklin could be looking at it from the back. I'm looking at it from the front. He says it's a positron. I say that it's an electron.
Yeah, okay. This is kind of
it's not a point of view though. It's not a point of view though, because he's got two rotations in there, and the two rotations, no matter how you look at them, their relativity to each other are always rotating. They're precessing. If you look at it, it is unique. You can't look at it from the back and the front and see that they look opposite each other. They will look the thing different if you really think through it, because of the two rotations.
Yeah, definitely one can think of four combinations, kind of, you have flow of one kind in one direction, flow in the other, and then the other direction, both of them in two different directions. So for example, here, if we look at this part of slide under B, we have here, say, one electron and the other electron, and then they are stacked on each other, what I mean? And then we have.
I think the point is that we would still be able to identify the same object as both a positron and an electron.
Okay, why not? I mean, wait a minute. I mean, okay. So, I mean, we may have this situation actually that positron, if it is not electron turned around here, it could be positron. It was a flow of electron where the equatorial flow is different, So I mean,
you would have to introduce something more complicated than just like
it's
like
not
a circular flow like you have here.
We have a circular flow. We have circular flow. Okay. We have circular flow, right? Here, circular flow. We have here toroidal flow, right? This is electric field. This is related to electric field. This is to magnetic field. So here have this situation, two electrons stacked on each other. So electric field is the flow, say, outside of the slide and inside here, and here the same. So as these arrows show, we have co-directional flow. That means reduced. That means not reduced gradient of velocity, actually, and then increase pressure, or maybe increase gradient velocity, increase pressure, and they get pushed to each other. If we will be turning out this one, then they will be attracting. Positron might be different, that actually its movement of its this movement around equator would be different, or so countersigned, you know. How say it? Photon is actually a combination of such two, kind of, maybe. But we have
I think
here,
the motivation is that no matter what your model is that if we declared something as a proton, you should be able to detect it as a proton no matter which way you look at it, right? And same thing for an electron, that if we determine that has a negative charge coming out of it, you should be able to, no matter how you look at it, determine that that's an electron.
I just said that. So if positron is electron, just with totally different directions with this flow, you know what I mean? But you know,
well, it can't be based on flow, because that can always be reversed by just mirror image.
Okay, I mean, why not? Why not? Very important thing. You have two forces of two signs. You know, four different combinations. They get into equilibrium. Whether they rotate one of each other quasi-statically, this is a different issue. I even have provided the framework with that kind of thermal gravitational oscillator formulation, where we have explicit attractive and repulsive forces and all four combinations. In whatever theory, your theory with positrons, electrons, epolars, David's how say it is combinations of what was that? Combination of two structures. You know, something that indicates what is dynamic stability, what is characteristic, what it is based is necessary. This is one insight that can provide a basis for everything. You know, if we have the configuration that can have dynamic stability, then that's fine.
But you do understand the basis of Bob's main question here.
Can you give Bill an opportunity to talk to this? Because I think he uses the same basic toroidal concept where you have a dual rotation, and he can probably clear it up too. But you know, I could explain it. But let's see what Bill has to say. He's had his flag raised a minute, and it might clear this up too.
Yep, go ahead, Bill, because I know that you also advise you are very much in this toroid camp.
Yeah. I had a question that might help clarify this, and that is in the ether dynamics that is being presented, does it deal with not only the electromagnetic force, but the force of gravity, the strong interaction force, and the weak interaction force? And does it explain the structure of elementary particles and the structure of atoms and that sort of thing? And
yes.
So that's the question I'm asking. Is it today we're trying to find the more universal solutions to things, and so okay.
Okay, so that part of with the structure of atoms, nucleons has been covered by this presentation and the related translated chapters or sub-chapters. On a couple of occasions, I communicate to you, Bill, through Roger Rydin and directly to you. I mean, for the possibility actually to explain stability of helium atom based on this particular configuration. I may draw some slides here, but not that quickly. But by all means, it is necessary to involve both electric and magnetic forces. You know, so for example, neutron has magnetic field, doesn't have electric field. Proton has both of them, and in their attachment or joinment, actually they orient and combine such a way that actually they provide some dynamical stability. They don't have to turn around each other, but kind of there is those movements, the flows that actually are supposed to ensure that stability. As it comes to gravity, gravitation, as I had shown with a couple of slides previously during some discussions in the email, gravitation is actually just effect of different gradients of pressure, temperature and pressure in the domains of one body and the other body. So one body, generally, what is interesting here, very, very important topic. I mean, it clashes with the second principle of thermodynamics, actually. We have formation of the ordered structures or ordered movement out of unordered. So out of higher temperature, we get structures with lower temperature, and they exchange temperature, exchange those particles, materials. And those material structures from neutron, proton, whatever, Earth, Sun, galaxy, they are cooling the surrounding ether. The cooling ether becomes less cooled farther away from particular body. That means temperature increases. That also means the pressure increases. So, for example, impact of sun as being cooling the ether is such that in domain of Earth there is gradient of temperature and gradient of pressure, and vice versa. So actually, we have this balance of pressure, and bodies are getting pushed toward each other. I mean, so there is explanation here that's really comprehensive, covering all the aspects. If people come from different perspectives, as I had come from just kind of orbital motion to be kind of oscillator tape or whatever, I mean, to overcome those issues with untenable conservation of energy and untenable conservation of angular momentum on particular substructures as orbital motion, sun, Earth, and planets, and so on. They can then use those elements, kind of complementary or to prove, to check, to add. So, here there is the issue. You see here that the Maxwell's equations totally extended. You still don't have them on the level of helium atom, or you still have just electric. You had those shells, which then repulse, attract each other, but it's a little bit different form than this one. So we can look at this. Let's say this your theory and the Tchaikovsky theory to explain or to provide configuration and whatever is necessary for a helium atom or alpha particle. So that will be the way to go. I mean,
well, what about strong interaction and weak interaction to explain the structure of elemental
they become electromagnetic interactions, essentially.
Everything is electromagnetic.
Yeah, as I said before, even gravitation can be electromagnetic, say, kind. So there is my insight is additional from this from the side that I came to is actually that kind of really unification of both structures and interactions on all scales, and exactly on phenomenological level we are dealing with these two forces, essentially 1 over r squared and 1 over r third, and then they just apply to all scales. Of course, there are some more, how to say, graduation, some more, maybe some need for some kind of refinement or whatever. But basically, that will be the topic. And I mean, they may provide some kind of really golden ratio relationship between structures and things like that. That will be really kind of this part of magic numbers goes along those lines. What you said about quantization of orbitals, that's also very, very, very important, and such effects should be shown by dynamics. And
well, I do have my own doubts as to whether
these two forces
can be 1 over r squared coming off of a toroidal structure. I mean, we have seen videos where they put dye into these toroidal structures, and pretty much the effect is totally localized. to the toroid so that the force basically drops to zero when it's outside of the actual ring. So it doesn't appear at all to extend 1 over r squared.
Look,
or any kind of r kind of force.
Macroscopically, you have to work with a container with gas under pressure and everything inside it, not air in water or maybe smoke ring in the air and things like that, you know. For example, macro level double slit experiment can be very, I believe, and I'm pretty much convinced, can be easily and very convincingly implemented. You will see how photon gets into two toroidal vortices, and then after splits into two, gets again to each other.
Well, you're essentially saying that we can't look at the toroids that we create, that we can actually see in water and air, that your toroids are something uniquely different than that.
You have out of water, in water, totally in water, out of air, totally in air, out of smoke, totally in smoke, you know, out of this, totally in that, you know what I mean? And ether turned out to be gaseous fluid of such and such characteristics, produced inductively, deductively, with experiments existing, additional, and so on. You know what I mean?
Well, are smoke rings a valid analogy for your toroids, or are they not?
Smoke rings in the smoke under pressure. You know what I mean?
But is it a valid analogy for Otapsky's toroids?
Don't talk about smoke rings. By the way, anyway, although just in air, those guys are really making very, very funny, interesting things on those videos.
I mean, this is a very important point. I mean, when we look at Otapsky's theories, I mean, are we looking at something which is analogous to a smoke ring, or are you saying that we can't do that?
It is that shape on the low scale, very, very low scale down there, you know. And we actually have shapes of that kind on or conglomerates of those shapes on higher scales, you know. So just kind of.
So you're saying that as an analogy, it would be a poor analogy, and that we can't say the same things that we see in smoke rings.
To be good analogy, I have to say, you have to look into smoke rings within the container with smoke under high pressure.
And what would change under high pressure?
High pressure is actually potential. This is the basic, most important thing, you know. So you have particles moving from each side, you know, with certain velocities, hitting every domain, every point, I would say, in the domain, you know. That's what pressure technically is, right?
Yeah, but do you understand the objection I'm raising here, which is that the effect that we see in smoke rings is highly localized? So that, you know, if I have an electron and it's 1 meter away from another electron, and it's a toroid, which has some kind of circular flow, those electrons are not going to interact at all. That that electron 1 meter away is not going to feel any effect at all from the other.
How do you know?
Electron.
How do you know? So look at this picture here. We are talking here about distributions of densities and velocities. You know, like here in this experimental results, right? This is quantum mechanical experiments, right? And we are talking here about kind of maybe something draw as a lines, right? That should be considered as kind of really kind of areas with maximal density. You know what I mean? This is counterpart. This is counterpart of quantum mechanical probability density function. You know, we have certain distribution, but not of probabilities. We have distributions of flows, velocities, densities, and so on. You don't have to look at it as a line. That's kind of just outline of certain distribution, you know, and it has been enough well indicated here, for example, in this whatever. Okay, see here, for example, here. Oh, let's see. Look here. Look at this. Look at it. Look at how far. But the point is that interaction goes as depending on distance between centers as r squared and r to the third. I mean, inverse value. And this is just based on Pascal, Bernoulli, and stuff. You know what I mean? Nothing else. No quantum mechanics, nothing. I mean, quantum mechanics just say, okay, you guys have measured everything in those distributions. Let's try with the distributions of flows and densities of that kind. That was the way how this guy approached in that particular segment. I mean.
Okay. Well, thank you very much, Slobodan. We are getting towards the end of the hour here. So I think we'll wrap things up. So thank you for presenting Otevsky's Ether-dinamics. I think it's a great thing that you're doing to translate his work and bring that to us. And you have provided a large number of links. There were links in the original conference. So if anyone wants to continue to pursue this and to contribute to ideas like this, I would recommend they get in contact with Slobodan. I have provided his email also in the original conference invitation. And that's what we're here for. We may not agree on how all these things work. I, for myself, have been, saying death to vortexes for a long time. So I'm certainly not someone to be unbiased in this area. But that doesn't mean that we shouldn't discuss it. And people should be able to present what they think are the problems or what are the solutions to this kind of thing. Because this is the only way we're going to figure out what's right or wrong. Although ultimately, I think we need to have some experiments to really determine what is the truth here. Because otherwise, it's just a bunch of words. But otherwise, this has been an interesting presentation. And I think our next conference will probably skip next week to 23rd, since that is Christmas, and we will continue our next discussion on the 30th. And I do believe I do have a speaker lined up for that. And but that will do it for this episode of the Saturday Science Chat. And like I said, we will see you here again on the 30th. All right. Thank you.
Thank you, Franklin.
Thank you, Franklin.
Thank you, Slobodan.
Thank you.
Thank you.